operate this, the first thing we need to do is transfer these decimals into a fraction. So let's start with that. So let's start with 0.73 infinite. The first thing we need to do is seeing these kind of problems as an algebraic operation. So basically is y equals to 0.73 infinite. Now what we need to do is multiply this 0.73 infinite by 100. So we're basically writing 100 as we divide by that, and the result of that is 73.33. We have two 3's because the only infinite number here is 3. Then we need to subtract these two, which will be a result of 72.6. Also this part, which will be 99y. This cannot be an answer because it is still a decimal and we need to have a whole number. The next thing to do is repeating the process, but this time with another number, which will be 990y, and the result of that will be 726. Now we have a whole number. The next step we need to do is dividing these two results to have the value of the y. For doing that, we need to do our y alone while we pass this. As here it is multiplying, it will be passed to divide. So we have now that we have here, the best thing we need to do and the most accurate to do is turning this into a smaller number. By doing that, we can take both parts divided by 66, which will make 11, denominator 15. That will be our answer. So we can say that 0.73 infinite is equal to this. That is our first part of this operation. Now that we have the first part, let's do the second part, which in this case is 0.05, but these two are infinites. So it is the same kind of process. We see this as an algebraic process, so y is equal to 0.05 infinite, and on top of that we're gonna put like the process when we multiply it by 100. In this case will be 100y, it's equal, and the result of this multiplied by 100 is 5.05. We can see that here it is not 5 as we previously do, and this is because the two numbers here are infinite, so we need to take into account that if we saw the whole number, it would be 5.050505, not only 5's. Now that we have here, as I previously explained, we subtract, and the result between 101, we know it's 99y, equal the subtraction between these, it's equal to 5, and in this case in the first try we have a whole number. Now the next thing is dividing to have our y alone, so y equals to 5, and in this case the 99 is multiplying, so as you know we pass to divide, so 99 it's here, and that will be our result. So we can say that 0.05 infinite is equal to 5 with 99 as denominator. Now the most important part of this problem, which is operating these two as they were the result of the other numbers. So by doing this, the simplest way to do that is simplify our numbers. In this case, we can simplify the 11 and the 99 by 11, which will be something like 1, because 11 divided by 11 is 1, and the 99 divided by 11 it is 9. These two other numbers, 15 and 5, can be simplified with the number 5, which will be 3 here and 1 here. So our multiplication have passed from this to this. Now we can operate this in an easier way. For doing that, we can just multiply each thing in a directly. So 1 times 1 it's equal to 1, and 3 times 9 it's equal to 27. So the first result of this will be this. The next step will be pass this to a decimal, especially a recurring decimal, as our problem states that is how we need to give our answer. So by doing that, we need to divide it. So would be. So let's operate this. 27 doesn't enter in 1, so let's put 0 here, a point, and let's add a 0 here. 27 does not enter in 10, so again, let's put a 0 here and a 0 here. 27, how many times is in 100? It is 3 times. So we put as 3 here. 27 times 3, it will be 81. And we subtract this. We cannot do that, so it become a 10. This become a 10 also because of this that gave us 1, so 10. But as we gave another 1 to this 0, it will be a 9, and this doesn't exist now. So 10 times minus 1 is 9, 9 minus 8 it is 1, and here we put nothing. So continuing, we again remember as we're doing this, we need to put a 0 here, and that 0 is going to go down, so 190. Then continuing it, how many times it is 27 in 1000, so it will be 7. 7 times 27, it will be 189. Which when we subtract this will be, we can do this, so 10, and this gave us 1, so 10 minus 1 is 1, 10 minus 9, sorry, it's 1, 8 minus 8 is 0, and 1 minus 1 is 0 again, so we have just 1. And remember, we have continuing zeros here that will drop here, and so on and so on. Now we can see that this number it's going to repeat itself every time, because it's the same situation that we have in the first place. So it will be our result being like 0, 3, 7, 0, 3, 7, and so on. That means that our result to this division is 0.037, and these three are infinites, and that is the result, our final result for that problem. To solve this problem is really easy. It can be seen as something difficult that will cause us problems because of the square roots, but it's actually really simple using the method I'm going to explain. For this, the most important thing to realize is that our square roots here are the same. These three are a square root of 2, which means that we can solve this problem taking that as an algebraic operation, which will be basically 3a times 4a times 5a. As we can see here, it is much easier to operate now that we don't have these kind of values that can confuse us. So now what we do is operate these numbers. We know that 3 times 4 is equal to 12, and 12 times 5 it's equal to 60. So that is our result for this times this times this. So we write it here. Now the next thing we need to realize is that we have 1, 2, 3 eighths, which is a times a times a, which is 10 power of 3. We write this in our answer as we need to put it. So a times power of 3. That will be our result, but we need to change it so it's in terms of this square root. So it would be basically the 60, as we know it's the result of the operation multiplying these three numbers, and we put this to not confuse us, and a square root of 2 taking as the same as this a, and we need to exponent 3 because 1, 2, and 3, and that means that this is our answer.